I want to talk about the rate of change during accommodation. So what kind of parameters is changing during accommodation process? So we explained that what is accommodation. During the accommodation, our eyes, when we are looking at far object, our eyes is relaxed like this. When we are doing accommodation, or our eyes in an accommodation situation, which means that you are looking at a close object to your face, then you put a lot of pressure on your lens, and actually not pressure, you remove tension from your lens, and your lens get more like a spherical shape, and uh, actually the optical power of your lens increase, and we call it accommodation process. And in another video I explain it in more details, but now let's look at the numbers. Actually, as I mentioned before, when we look at far object, let's say at infinity, like this house very far from you, the optical power of the lens itself is 19 to 22, which is a very good range for healthy eye. Now, when you look at an object is pretty close to your face, like this kid, 10 centimeter from your face, your optical power of your lens increased by 13 diopter. So we should keep this number in our mind. And this range, the range that you can see an object close and far, when it is very, very far, you cannot see it. When it's very close, you cannot see it like a sharp image. It's going to be a blurry image. And this range, we call it accommodation range. The range that you can see the furthest object to the range that you can see the closest object. And your eye can tolerate that distance. We call it accommodation range. So now let's look at some numbers. Actually, during that accommodation process, a lot of things changes. Those are some studies about how are actually as you remember, I said the full accommodation range here. I mentioned 13 diopter. So right now we want to talk about in between. So from the extreme to the least extreme is 13. Now we want to see how much the other optical elements of our eye is changing per diopter. So let's say, for example, the anterior radius of curvature, which is for the lens, per diopter is negative 0.62. So it means that for each accommodation, for each 1 diopter accommodation, that parameter changed by negative 0.62. And which makes sense. It should be changed. And then this is the method that they use for that measurement. In 1997, Purkinje imaging, that's the method that they use for that measurement. In 2022, negative 0.47. So when you look at the data, it looks like we have a good range that is between negative 0.5 to negative 0.6. So that's a very well. And then in Zmax model you can use those numbers actually. So, and then the posterior radius of curvature, that one is negative. That one is also changed because the lens from both sides change the radius of curvature. So per 1 diopter is negative 0.17, 0.13, 0.15. As I always said, for posterior radius of curvature, we don't have that much of data because it goes inside of our eye, and the measurement is harder and harder, and it's passing from the light is passing from the other surface, so it's harder to measure it. And the other parameter is anterior surface asphericity also. That one is changing. You should look at my previous videos. What is asphericity? Q factor, being far from a spherical shape. That one is also changing, negative 0.36. Posterior surface asphericity, that one is also changing, plus 0.3. So there are a few research on those parameters, and they suggest that even those are a kind of parameters that change during accommodation from the range that I mentioned. Let's say plus 13 diopter. In that range, those numbers are changing. The other parameter is axial thickness. So the thickness of the lens is also changing, which is obvious that when the diopter increase, the thickness should be, when the actually the optical power increase, the thickness, because we press it from both sides, the thickness should increase. But that number is not that big, actually 50 micron per diop. So at maximum we can actually calculate 13 multiplied by 50 micron, and you can see the range based on the researches. For example, in 1999 using MRI, it's about 0.05 or 50 microns, and we have standard deviation for those numbers, and those numbers are pretty close, not that far from each other. So we have a set of data for actually axial thickness also, and there is a little bit research about the refractive index also, but I think we don't need to talk about it because it's not very well-known effect, that because of the pressure on the lens the refractive index is changing, but we don't want to discuss it that much because that change is very, very small and it can be neglected. So the lens diameter also, because it's obvious when you press something, this diameter, we are talking about the, let's say we can say the clear aperture. If we look at it from pure optical perspective, the clear aperture is changing, so that diameter is changing, negative 0.7798 in that range. We have some studies which predict a big number, but most of them are in that range actually. Thank you very much. That's all for this video, and here are some references that I used.